Hello again, Year 9, our last lesson of the year, and it's not too long. It's got a couple of main things that we're going to cover here, and after that the summer is your own. Now your do now is on this slide here. You've got a graph, you know it's a graph because it's got two axes. On the y-axis it's got temperature increasing, and on the bottom axis, the x-axis, it's got energy increases, goes from left to right. And we know, of course, that as temperature increases, the energy that particles within solids, liquids and gases have changes. We know that the particles don't actually change size, they don't get bigger or smaller. Very important when you have the three square boxes here, 1, 2, 3, and you need to draw your particle diagrams, make sure they're the same size in each box. And you've got 4 labels, and you can have a look. You've got a solid, a liquid and a gas here, so this is all about change of state. So it doesn't need to be perfectly drawn, just needs to be sketched with the labels to go inside the arrows, the diagrams to go inside the box, and you can pause the video while you do that now. And here's your answer. You should already know freezing and melting. You should know evaporation and condensation. That's the one that people most often get stuck on. You've got your particles here, solid, all equally arranged in a nice lattice arrangement. Liquid, same size of particles, but they're more of a random arrangement. They're not neatly stacked anymore. Gas, same size particles, much larger spaces. They've got more energy, they can move around more. That is why gases, you only have a few particles in a large space. Right, today's objectives. You're going to know the products when hydrocarbons are burnt in a good supply of air. You're going to know how to test for the products. This is a key GCSE objective. That's why we're covering it now, to give you a head start before you go back to it in year 10. You're going to know why carbon monoxide, please notice this word there, is given off during incomplete combustion. And then we're going to know how to write balanced equations for complete combustion. I'm sure I can hear the groans already, but actually combustion equations are some of the easiest ones to balance, which is why I thought we'd do a little bit of that today, because then we'll remember quite how amazing we all are. So let's start off. Complete combustion. I've got a dictionary definition from the Cambridge Dictionary. Combustion is the chemical process in which substances mix with oxygen in the air to produce heat and light. You probably actually know it as burning, but within science we call it combustion, which is why the engines in cars are called internal combustion engines, because the petrol or diesel within those engines is burnt, combusted in air. Now, when you have crude oil, the lighter fractions, such as propane gas, are very useful as fuel sources. And the balanced equation for propane is shown below, which shows you propane plus oxygen becomes carbon dioxide and water. The things to remember here, where you've got a little subscript immediately after the letter of an element, that shows you there's 3 carbons, 8 hydrogens. You've got a number 5 in front of the oxygen here. That means there's 5 lots of everything in there, so that's 5 times 2, so that's 10 lots of oxygen. We've got carbon dioxide, 3 CO2 means 3 carbon and 3 lots of 2 oxygen. So you've got the big number in front, multiplies everything that comes after. It's as though there's invisible brackets. You're more used to doing equations in maths. So when you have an oxidising reaction, both the carbon and the hydrogen from the propane are fully oxidised. The products for all hydrocarbons that are completely combusted are really, really easy. They are always water and they are always carbon dioxide. That's why these are nice, easy equations to balance, because you know what the products are going to be before you've even started. So, in the words of the song, you're already halfway there. Oh, we don't need to do a chemistry prayer. So, many hydrocarbons are oxidised by vehicles in factories and to generate electricity. Now, obviously, if you know that the products are water and carbon dioxide, water isn't a problem, but carbon dioxide is. This is what's called a greenhouse gas, and it's one of the causes behind climate change. Now, you're wondering how I prove this to you. Obviously, we can't do a practical at the moment, and I do not have a Bunsen burner at home, not least because I do not have a gas cooker. So what we would normally do is you'd have natural gas that comes into your Bunsen burner. It's a hydrocarbon, we can use that. Now you've got a Bunsen burner here, you've got the flame is an orange one because the air hole is closed. You see the label there, you see the diagram here, two ways of checking that. Then you've got a complicated arrangement with funnels and tubes and bungs. This means that you can capture the gases because this happens at heat. The water and the carbon dioxide that are produced are both gases, and they come along here through these tubes into a U-shaped tube, and that has got ice surrounding it. The reason it's got ice, going back to our diagram at the beginning, is you're going to cool it, you're going to reduce the amount of energy that the gas particles have, and the water will condense first because we know that it only needs to get below 100 degrees to change back from being water vapour to being water liquid. And then here you've got something called cobalt chloride paper that starts off blue, and if you get some water, that will condense and that will show a reaction. You've still got gases coming out though, and those are bubbling through something called lime water, and there's a pump here that just pulls all the gases through continuously. It acts like a vacuum. Yeah. Now the lime water starts off as a clear liquid, and it will become cloudy if carbon dioxide is present. Is cloudy because a chemical reaction occurs and there is carbonate is precipitated, which means you get tiny little solid particles within the liquid, which makes it look cloudy. You're doing this in a lab. Obviously you need to wear eye protection. Cobalt chloride papers, because they react to water, you want to handle them as little as possible, preferably with some forceps, because you don't want water from your hands getting on and affecting the results. So what happens? Carbon dioxide bubbled through lime water, clear liquid will turn milky white. This is a classic question in chemistry GCSE or in combined science GCSE. Test for carbon dioxide is to bubble it through lime water, which will then turn milky white. Water is tested for by using cobalt chloride paper, which changes from blue when it's dried out to pink if you've got water. The other thing you can do is you can use anhydrous. Anhydrous means without water. Yeah, we know that hydrated means something has had water added to it. So you get hydrated when you drink a drink of water. Plants and animals can become dehydrated. When we're talking about chemicals, instead of saying dehydrated, we say anhydrous. Copper sulfate, that starts out white. If water passes over it, it will turn blue to the colour that you would think of more commonly for copper sulfate. Obviously we're not going to test that the liquid is water by tasting it, because if it weren't, that would be very dangerous, and we never taste anything in a lab. So that's quite straightforward. You do need to write those two tests down, and then you need to learn them. Not too tricky though, I agree. Pause the video while you do that. Okay, so now here comes the slightly trickier part. Now what I've done here, you've got the title at the top, Balancing a Complete Combustion Equation. On the left hand side, I'm going to show you the steps in balancing the equation. On the right hand side, I'm going to show you the success criteria that you will use every time to do the same thing yourself. So we've got one that we'll work through together, and then you've got some that you'll do on your own, and you can send them to me to check for you. So the question is going to say, write a balanced equation for butane fully combusted in air. And that's just telling you that is the question. Next step. First of all, highlight the substances and write in their chemical formulae. Butane, luckily you learnt that last week, we learnt about alkanes, so you've got a table to look it up in. It's C4H10. Combusted in air. Now air has lots and lots and lots of different gases in it. The only part we need to worry about is the O2, the oxygen, because it's a combustion reaction. You don't need to worry about the nitrogen, the argon, anything like that. They'd be there at the beginning, there at the end, not doing anything, so we're not going to write them in. It doesn't change the equation. So make sure you're writing these out as you go along. So first step is to highlight the substances. Second step, add in the known products to make a chemical equation. So we know we've got C4H10, we know we've got O2, we've got an arrow showing our direction of change because it is a chemical reaction, and we've got CO2, carbon dioxide and water, H2O. You'll know both of those already. So far so good, 2 steps. Step 3. Count how many of each element on each side. So carbon, at the beginning there's 4 on the left hand side, 1 on the right hand side, not balanced. Hydrogen, 10 on the left and 2 on the right. Oxygen, 2 on the left because it's O2 and 3 on the right because you've got 2 in the carbon dioxide and 1 in the water. So none of these are balanced. Straightforward so far. I'm sure that none of you have got any problems yet. Now comes the slightly tricky bit. Now, when you are balancing a combustion equation, you always balance the elements in the same order. And so all you need to remember is the order they go. So first of all, we're going to balance the carbon. I've highlighted it in pink. I put the changes in pink. So we've got 4 carbons here, and that means we need to have 4 here because 4 is the same as 4. So I'm going to put a 4 in front of the carbon dioxide molecule because that means there's been 4 times 1 carbon, but it does change the oxygen because you've got 4 times 2 is 8. This one here is still there plus 1, so you've got 8 plus 1, so that's 9 oxygens. I put it as 2 steps so you can see where the 9 comes from. Remember, you pause the video as you write these out in your books, and as well as writing the equation, write out the steps because you're going to use the steps when you do your own equations later on. Next step, you balance the hydrogens. So first it's C, then it's H. Now, we could just do 5 times 2 to make it 10. But if you did that, you'd end up with an odd number of oxygen. And that won't work because oxygen is always in an even numbered molecule. So that's why we're going to put 10 here. And then that will actually mean 10 times 1 is 10. And we're going to have to change the carbon slightly. A little bit tricky. I'm not going to read it out to you. You can check it out. Talk to yourself about it as you go. Each time I've done a change, I've used the colour pens to match the bit that we're balancing at the time to try and make it easy for you. Third one, final step now. Okay, now you have to balance the oxygen. First we've done carbon, then we've done hydrogen, now we're doing oxygen. And we leave this to last because it's an element, not a compound, so that makes it easier. And then at the bottom I have written out the whole new balanced equation just to make it nice and clear for whoever's checking it. If you're not sure about this, you should have written it all out. You can go through it and check the steps. Of course, you can message me. I am online through school hours and then quite a bit later as well in the afternoon. Do stop by before 7 o'clock though, so if you do it in the evening, that is fine, but I might not get back to you to the next day. Now you have got some more to practice. You've got numbers 2, 3, 4, 5 and 6 because you've already done number 1. These are all alkanes. They've all got oxygen. We know already what the products are going to be. The products are going to be water and carbon dioxide. And then it's just a quick question of going through the steps, balancing first the carbon, then the hydrogen, then the oxygen. Show all the steps in your working out. Do not give me a start and an end without any steps, because if you do, I cannot help you if it's gone wrong because I'm good, but I'm not able to psychically read the minds of everybody in Year 9 that are submitting these. The other thing you need to do is you need to get in the steps, practice of showing all the steps in equations, because if you do make a mistake, a mathematical mistake, you will get marks for the steps leading up to it. And a question like this would be worth 3 or 4 marks. So even if you make a mistake right at the end on balancing the oxygen, you could still get the other marks. And it'd be a shame not to get those. Last thing, a little bit scary, you might have seen these at home. Now if you have incomplete combustion, which means there's not enough oxygen for it to burn completely, then instead of getting water and carbon dioxide, you still get water, but instead of carbon dioxide you get carbon monoxide. Now carbon monoxide is quite nasty. It's a colourless, odourless, toxic gas. So for that reason you will have an alarm like this, a carbon monoxide alarm. in your house. There should be one by your boiler, and if you have got a log burner indoors, you may well have them with your log burners as well. And the reason is, as it is colourless and odourless, you won't be able to tell it's there. All it does is it makes you very sleepy, because it will bind to the red blood cells in your blood instead of oxygen, and therefore you'll become short of oxygen, you'll become sleepy, and eventually, sadly, you can actually die. So it's really important. That's one of the reasons that you have to get your boilers checked every year. So I think this is quite straightforward. Hopefully you do too. You know where I am. I'm going to make the end date Friday this time, just because it's the end of term. If you submit it late, I will have a look at it, but I can't guarantee exactly when I will do that, because apparently I'm allowed some holiday too. So it has been an absolute pleasure, Year 9. I have been so impressed with how much work you have done during this unusual time. I really look forward to teaching some of you next year, but catching up with all of you when we're all back in school together. Have a great final week and a fantastic and safe summer break. See you in September. Goodbye for now. Okay.